Today, we're going to talk about the single most important piece of tech behind this whole AI revolution. It's an architecture so powerful it can write, it can code, and now it can even see.
So, let's kick things off with a pretty wild statement from a top AI researcher, Leon Jones. He says he's, quote, absolutely sick of transformers. And that's a really big deal because transformers are the engine behind basically every major AI model you've ever heard of.
And here is the kicker. Leon Jones was one of the authors on that legendary 2017 paper, Attention is All You Need. He was on the original Google team. He even came up with the name Transformer. So what is going on here? Why would an inventor be sick of his own world-changing creation? Well, to figure that out, we first have to understand what a transformer actually is.
Okay, so to really get a handle on his frustration, we need to take a quick look at the architecture that really started this whole fire. First off, a transformer isn't some robot from the movies. It's a type of neural network. Now, what made it so different is that older models had to read text one word at a time. A transformer, on the other hand, looks at the entire sentence, or heck, even the whole document all at once. This ability to see the whole picture is what gives it such a deep understanding of context. So how does it pull this off? The secret sauce, the big idea, is something called the self-attention mechanism. It's a fancy term, but it basically lets the model figure out how important every single word is in relation to all the other words around it.
Now, this might sound super technical, but we can actually explain it with something you do every single day, a web search. Think about it like this. The word the AI is trying to figure out, that's your query. It then scans all the other words in the text. Those are the keys, like the titles of web pages. When it finds a really relevant key, it grabs the information associated with it, which is the value. It does this for everything, all at once, building this rich map of how everything connects.
And the impact? It was earth-shattering. Every single major large language model you've heard of, GPT, BERT, Llama, Gemini, all of them, they are all built on this transformer architecture. It completely took over the world of language AI. But its reign didn't stop there.
So once they'd cracked language, researchers started looking at an even crazier challenge. Could you teach this word-based model how to actually see images?
And you got to admit, that seems kind of impossible, right? An architecture designed for sentences, trying to process pixels, it just doesn't sound like it should work. But the solution they came up with is just brilliantly simple. See, instead of feeding the model raw pixels, they decided to treat an image like a sentence. First, you slice the image up into a bunch of little square patches. Then, you turn each of those patches into a string of numbers, a token. And all of a sudden, you have a sequence of image tokens that the transformer can read just like it reads a sequence of words. It's such a clever, elegant idea.
And this approach has had some profound real-world applications, especially in a field like medicine. Now, this slide shows a super complex architecture called TransUnit, which is used for medical scans. You do not need to understand all these little boxes and arrows. The key thing to know is that it blends the strengths of older AI models with the incredible contextual power of transformers.
So what does that actually mean? It means you have an AI that can look at a CT scan and perfectly outline an organ. Or, and this is huge, flag a tiny little anomaly that a human doctor might miss. It's an unbelievably powerful tool. Which brings us all the way back to our big question. If this tech is so amazing, why is its creator so sick of it?
And this gets us back to that central puzzle. There's a really powerful metaphor that's been floating around the AI community that I think explains this frustration perfectly.
This quote from an online discussion just nails the feeling. The idea is that the transformer architecture is like this incredibly rich gold mine full of potential. But instead of digging deeper for new discoveries, the industry is just stuck at the entrance, playing around.
This really comes down to a split in what everyone is focused on. You've got the alchemy lab, which is where most of the big money is right now. This is all about making the output shinier, making models that can write longer stuff or handle bigger documents. It's about making a product that wows investors. But then there's mining for gold. This is about improving the model's internal reasoning, making it more efficient, and giving it actual cognitive skills. It's about training it to think better, not just talk more.
And according to Jones, this has led to a calcification of research. Like it's hardening, getting stuck. Everyone is so focused on tweaking the same successful formula that they might be completely missing the next massive breakthrough.
And the reasons for this are probably pretty familiar. There's just immense pressure from investors who want to see a return on the billions they've put in. You've got researchers in this super competitive field who feel like they have to go for the safe bet, the small improvement, instead of a risky new idea.
And let's be honest, it's just plain easier to keep polishing the gold nugget you already have than it is to start digging for a whole new vein.
So what's the path forward then? How do we get out of this alchemy lab and back to some real mining?
Well, researchers actually have a really clear roadmap of the big challenges they need to solve. For one, these transformers are outrageously expensive to train and run. They can also be kind of fragile. They get confused if an object is partly hidden or if someone tries to trick them with a weird image. We also still don't really know why they make the decisions they make. It's a bit of a black box. And getting them to work well in totally new areas like robotics or analyzing satellite data is still a major hurdle.
And here's the thing. Solving these huge fundamental problems, that's not something you can do in the alchemy lab. You can't just polish the surface and make these issues go away. It means researchers have to get back to the hard, messy work of basic research. You know, the actual mining for gold.
Which leaves us with this one final fascinating question to chew on. The transformer is, no doubt, one of the most powerful ideas in the entire history of AI. But is this the end of the road? Is this AI's final form? Or is it just the incredibly powerful, world-changing pickaxe that will finally help us break through to whatever comes next?